morning students, myself Mithun, Assistant Professor in Department of Computer Science and Engineering, St. Joseph Institute of Technology, Chennai. Today we discuss about the half adder. So what is mean by half adder? The logic system performs addition operation. So we want to perform the addition operation from the logic circuit. So initially for every logic system we have the block diagram. For that half adder also we have this block diagram. So we have taken as two inputs and the output should be sum and carry for the half adder. So we mention it as sum and carry, so S and M for the output. So input variables such as A and B we taken out, and this is the overall block diagram for the half adder. From the block diagram we want to construct the truth table. So in this block diagram that represent A and B as the input variables and sum and carry as the output variables S and C. For this we want to create the truth table numbers. So initially 2 power 2 basic half adder circuit we want to create. So initially 2 power 2 is 4 variables input and 4 outputs we want to get. So that wise from 0, 1, 2, 3 decimal numbers are taken out, and then corresponding binary digits are we want to write the same as A as 0 as 0 0, 1 as 1 0 1, and 2 as 1 0, and 3 as 1 and 1. The half adder circuit, it perform basic addition operation. So we want to addition the two numbers and we want to get sum and carry. Carry is a additional bit. So from that, from basic 0 plus 0, from look at this, 0 plus 0 equal to 0. So we get the sum as 0, and carry, there is no carry, so no additional bits. So 0 as a carry value. So next one, 0 and 1. 0 plus 1 equal to 1. So sum as 1 and carry as there is no additional bit, so as carry 0. The next one same way, 0 and 1. 0 plus 1 equal to same as the previous one. So 1 as a sum and there is no additional bits, so it has 0. The last one is 1 plus 1. So 1 plus 1 equal to 2. The corresponding from the 2, the corresponding binary digits for 2 is 1 and 0. Okay, from that the logic of the digital circuit, from the least significant bit and the most significant bit, we want to consider from the left position of the bits. So 0 as the sum value and take 1 as the carry value. So same way sum as 0 and 1 as carry value. After that, from the truth table we want to create the K map for the both carry and sum. So in this there are two variables A and B, and another one we want to enter the numbers from the sum truth table and the carry truth table. Okay, for corresponding carry we want to take the numbers from carry, the corresponding sum numbers we take note for the sum K map values. So from that A, B variables are taken out for carry. So same way, that is 0, 1, 2, 3. So corresponding decimal numbers, we want to enter the numbers in the truth table for the carry. 0, 0, 0, 1, 0, 0, 0, 1. So we taken out, and we want to create the variables for the, that means equations for the logic symbol, for the logic diagram. So 0, 0, 0, 1. We want to map the variable as 1. We want to map 1 for the, to create the equation. So in this one as single one is there. So we map as from A. So A from B or B, we get the carry equation. Then another one for the sum, we from the sum truth table 0, 1, 1, 0. For this 0, 1, 1, 0. There is no possibilities for this one to map. So for that individual mapping is carried out. For this A B bar plus B A bar. So A bar B plus A B bar. From that, this equation shows the XOR value of the equation. So we want to change from this term A XOR of B. So the above equation represent the XOR equation. So that wise we use for sum A XOR of B. From the sum equation and the carry equation, we want to the logic diagram for this equation. Initially, first we taken out the large block diagram of the half adder, then followed by truth table. Then we want to calculate sum and carry in the truth table, and we want to create the K map. Why we want to create the K map? From the K map we want to create the variables. That means from the variables we want to create the equation for the logic diagram. From the logic diagram we can able to represent the half adder working module. Okay, so from that block diagram we want to conclude with logic diagram. So we already know that block diagram of half adder represents the two variables, the input and A and B. So this is A and this is B. So from that first we want to map the sum and followed by carry. So sum is A XOR of B. Okay, so A input is taken out, second one B input is taken out. For this XOR logic symbol from the basic logic gates, we want to draw the XOR logic diagram for this sum. This is the XOR logic symbol from the basic logic gates. From that, same input A and same input B are taken out for the carry diagram. So A into B. So from the basic logic diagram, A into B, it represents the AND gate. So AND gate symbol we want to write. So from the logic diagram we can able to add both sum and carry one single logic diagram. From the logic diagram we can able to showcase the flow of the half adder circuit. So initially once again I tell the overall flow of the half adder. From the half adder and from the half subtractor we can able to form the full adder and the full subtractor circuits for the 0 to 15 decimal values. From this it can able to showcase the 0 to 3 decimal values base to represent the sum and carry with this logic diagram. So first initially starts with block diagram. We have taken out the two input variables with and output variable as sum and carry S and S. From the truth table we can find out the sum and carry values. From that value we draw the K map for carry and sum individually. From this K map we can able to identify the equations for a sum and carry. From that equation we can able to draw the logic diagram for full half adder circuit. Students, we see the half subtractor. We already see the half adder circuit, the same followed by the full subtractor. So write down the key points. Opposite of the binary adder is the half subtractor. Next one, it subtracts two binary information from each other. That means from A and B. Third one, the output is difference and the borrow. The output is denoted as difference and borrow. Difference is D and borrow is B. And another one, definition for half subtractor. Half subtractor is the combinational circuit that subtracts two bits and produce the difference and borrow. This is the half subtractor definition. Once again I tell, a half subtractor is the combinational circuit that subtracts two bits and produce the difference and one borrow. Okay, let me show the block diagram for the half subtractor. Here they say from the definition, Then we take note the two input bits A and B, it represented as A and B, and this is the half adder logic, and it produces difference D and borrow B. So the same way for the adder we want to create the truth table, the followed by K map and the followed by logic diagram. As the search we want to create the same truth table and K map logic diagram for the half subtractor. So let's see the truth table. So the same way we want to take 2 bits na. So 2 bits means A and B as the variable, we represent as the 2 bits variables, so input as A and B. And another one, it creates the difference and borrow for the outputs, so it represents as difference and borrow, or otherwise we denoted as D and B. For this 2 bits, 2 power 2 is equal to 4 bit variables, it produces 4 bit outputs. So the same way 0, 1, 2, 3 as the decimal values, we want to write the 2 input A and B for the binary digits for 0 and 1 and 2 and 3. From this 2 bits we want to difference the 2 bits and get the difference and borrow. The same simplest subtraction should be followed. So let us see one by one. So for the decimal value 0, 0, 0 is the binary digits. So 0 minus 0 is 0. This is the difference. So we take as 0. There is no borrow, so they put as 0. The second one, and the second one is 0, 1. 0 minus 1, we want to borrow from some other values, or we want to imagine that one, so it should be as 10. 10 means it represents as 2, so 2 minus 1 is equal to 1. Okay, it should be represent as, what is the value for the binary digits for the 1? So 0, 1. Okay, 0, 1. So we already borrow something na, so we want to write 1 as in the borrow, and for our answer is 1, so it should be written as 1. The third one, for the decimal value 2, 1, 0 we want to minus. 1 minus 0, there is no subtraction followed, so it written as 1, so difference is 1. There is no need of borrowing anything, so put as 0. And final one, 1 minus 0. The same way, 1 minus 0. As 1 minus 0 is 1. So you want to put 1 minus 1. Okay? 1 minus 1, it should be 0. So put difference as 0, and there is no need of borrow in this. So we put 0 in the borrow table. From this basic operation of the subtraction, we conclude the truth table for the 2 variables A and B, that means 2 bits. For the 2 bits, 2 power 2 is a 4 bits values. We want to generate 4 bit outputs for the both difference and borrow. So the same way 0, 1, 2, 3, for these values corresponding binary digits are inserted and corresponding difference and borrow is generated from the basic operation. Okay va? Okay. And another one, we want to, from the truth table, we want to create the equation for both difference and borrow. This is the, from how we create this equation, from this K map only we can able to create the equation for both difference and borrow, such a way that we can take the difference value for this K map and borrow value for this K map. We want to map the 1 for the mapping, and from that 1 mapping we can able to get the difference equation. For example, difference 0, 1, 1, 0, 0, 1, 1, 0. From this 0, 1, 2, 3 is the decimal value. From the decimal value we can insert the difference value 0, 1, 1, 0. The single one is there, so we can able to map 1 and 1 only. So for this one, A and B bar, A and B bar plus. So another one, this from for this one, B and A bar. So B and A bar. Okay, like that we can able to, for this equation it represents the same XOR equation. So we put XOR symbol for the A and B. So we can able to generate the equation from the difference K-map. From the truth table we can identify the difference equation. So for the same procedure followed a bar also 0 1 0 0 0 1 0 0. For that equation we want to generate one, we can able to map 1. So from this one A bar B, so A bar B we can able to get the equation for bar O also. From the truth table we can produce the equation for difference and bar O. The same procedure followed for half adder also. From the half adder and the half subtractor we can able to produce the full adder circuit and the full subtractor circuit for the decimal values 0 to 15. Okay. From that block diagram we can able to create the truth table. For this truth table we can able to create the equations. At last finally we want to conclude with the logic diagram for this equation. Let us see. This is the equation for difference. This is the equation for bar O. It denoted as D. It denoted as B. Okay. Send for the logic diagram we can input as A and B. From the same XOR operation, XOR symbol, from the basic logic gate of the XOR gates we can use this value for difference. Okay. It should be noted as difference D. Okay. Another one, for this bar O, the same input from A and the same input from B can taken out, and for this A bar it should be mentioned as NOT gate. This symbol represents the NOT gate representation. So from the NOT gate A bar is generated. So A bar into B. So A bar into B as the AND representation. So AND gate is used. For this AND gate we can finalize the bar O symbol B. Okay. The same circuit shows in the half adder also, but only one change is the opposite of the half adder is the half subtractor. The same way followed for 0 to 15 values for the full adder, and the opposite of the full adder is the full subtractor. From this, students, we can able to form the logic diagram for both half adder and the half subtractor. You should write from the basic block diagram for the half adder and the half subtractor by 2 input variables and the 2 output difference and bar O. The same way for adder, so sum and carry. For the symbol should be noted. Second one, truth table. For the truth table, if we use half subtractor and half adder, 2 power 2 variables, so 4 bit difference and 4 bit bar O. The same way 4 bit sum and 4 bit carry also generator. From that values we can generate the K map and map the 1 values and generate the difference bar O equation. Same way carry and sum equation. From the carry and sum equation we want to draw the logic diagram. From the input should be noted, for the difference and bar O should be noted with these equations. The same way for carry and the sum, it should be proper notification for the AND gate also, AND and NOT gate also. So hope you understand both the concept of half adder and the half subtractor. Thank you.